Today we'll see derivative of composite functions. So before starting this, I just giving you one example. So all of you know how to find the derivative of this function 2x plus 1 whole cube. So for finding the derivative of this, what you will do, either you will expand it, so it will be d over dx of 2x plus 1 whole cube will be how much? You can expand it with the whole cube formula, so it will be 8x cube, cube of the first one, plus 1 plus a square b, so that will be 4x square into 3a square b plus 3ab square, so 3 into 2x. So this will be your expansion of this one. Now you have to find out the derivative of this. So derivative of the first term 8x cube will be how much? 24x square. Derivative of 1 will be 0. Then derivative of 12x square will be 24x, that you know. Then plus derivative of 6x will be only 6. So this will be the derivative of this. But here we have expanded it and then we have differentiated. Now if in case in this we don't want to expand it, okay, so this thing is looking like x, means we are replacing this with fx, so it will become fx whole cube, the function. This can be written as cube of fx. Okay, so in these type of differentiation, what you can do, you can simply write this as fx whole cube. So while finding the derivative of this, so you know what is the derivative of x cube or fx whole cube? It will be just 3 fx square. Okay, something raised to the power 3, the derivative of something raised to the power 3 will be 3 that something square. Okay, now but we have taken this as fx, this was not our x, so we have to find out the derivative of this fx again. So here this will be 3 into, now you can replace your fx, that was 2x plus 1 whole square, and then f dash x will be d over dx of your 2x plus 1. So how much you will get? So that will be 2 only. So here you will get 3 into 2x plus 1 whole square into 2 only. So your answer will be 6 into 2x plus 1 whole square. So you have seen. So see, you have seen this question we have done in 2 different ways. So the later one, the second one, this method is known as the chain rule. Here you have function of another function. So here we have used the chain rule. Here I've taken some examples. Let's see how can we find out the derivative of these. So see this one, the first one, cos of sine x. So you know the differentiation of cos x, but here we have this sine x. And here sec x you know, but the differentiation of sec 10 root x. So this one you can substitute, or you can take this as fx. Okay, so in these type of questions we will take this one as fx. Okay, so now you have, if you have to find out the differentiation of first one, that is d over dx of cos, this one I have taken as fx. So the differentiation of this will be, differentiation of cos you know already, it is minus sine, just whatever it is, write the fx as it is. Then the next step will be finding the differentiation of the fx. So this is the chain rule that you have to apply. Now the sine fx will come as it is. So what was the fx? Fx was just sine x, and now you have to find the derivative of that fx, that is sine x. So it will be minus sine of sine x, and here the differentiation of sine is cos x, so your answer will be this. So here you have seen what we have done here. We have taken this fx, sine x was your fx. So here what we have done, cos of fx was sine fx only, and you have to do the differentiation of this fx again. So here the same function, the fx will come, and here you have to write down the derivative of that one. So this way you can apply the chain rule. So I hope this one is clear. Now let's see the second example. Like I've explained earlier already that you will take this one as your fx. Okay, so now if you're finding the derivative of d or dx of sec, then here whole thing we have taken as fx, or you can substitute it with the t or u or any other also. So here what is the differentiation of sec fx or sec x? It's sec x tan x. So sec of fx into tan of fx you will get, and afterward you have to find out the derivative of fx. So this will reduce to, you have sec, in the place of fx you can put the value, so it is tan of root x, here as well tan of root x, tan of tan root x. Okay, tan was already there, and then this fx, then multiplied by f dash x, so that is d or dx of tan root x. Now again here you have to apply this chain rule, because tan x, differentiation of tan x you know, but here again you have this root x. Okay, so here we have to apply this chain rule again. So this one will be these part will come as it is, up to this it will come as it is. So it is sec of tan root x and then tan of tan root x, all this will come as it is. Only now you have to do the differentiation of this part, so that will be here. So again this one will be how much? Tan of root x, so differentiation of tan is sec square, so it will be sec square of fx, and then now here this is your fx, then differentiation of fx again, so it will be sec square fx will come, I will write this fx later. So differentiation of fx here, d over dx of root x is how much? D over dx of root x is 1 by 2 root x. So the remaining term we can write as it is. So here this will be your answer. Just take a look once again. So here in the beginning this was our fx, so here fx was just this one, 10 root x. Here also 10 root x will come, and here we will do the differentiation of this. So here we have done the differentiation, here this function came. Now afterward, next time we have taken some other function as your fx, so that function was this one root x. So now here we have taken this fx, root x was your fx, so here the differentiation of that we have done. So here it is root x, here we have also root x, so then we have done the differentiation of root x, so we got this 1 by root over x. So final answer will be 1 by 2 root x sec 10 in 10 root x, 10 of 10 to root x into sec square root x. So this is your answer for this question. So I hope this chain rule is clear to you.